Welcome to the Machine Learning Essentials series. In this video, we're going to learn about machine learning and how it's better in the cloud. But first, let's start with programming. Functions are a fundamental unit of programming. They basically convert input into desired output. These things are easy to make and test when really there's just one person on it. But it becomes harder when more people are involved and a larger set of folks rely on what is made. The cloud has made it easier to program these things, from shared development with source control, builds, testing, monitoring, and automated deployments with DevOps. Now, just like regular programming, models are the basic unit of machine learning. The output of machine learning are really these models. Trained models are exactly like functions. They convert input into desired output. For example, give it a picture and it says horse. Give it an audio file and maybe it will give you the text of what was spoken. Instead of programming models, though, we need to train them with existing data. So let's talk about building and training these models. Making machine learning models can sometimes be more of an art than a science. They're not magically produced. You need to start with a sharp question and data that, well, in theory, could answer that question. Generally, the more data available, the better the model can be. And again, it's not magic. Folks also need to build a model shape. Expert data scientists have a sense for what model shapes go well with the data that is used to train the model. There is a wide array of model types to choose from, and for each choice of model, there are many levers or parameters that can be used to build them. This often comes about through meticulous analysis of the data. Now, training these things locally can be cumbersome depending on the amount of data and the size of the model. The two steps of this process are to build a model and then to train it. Let's talk about the challenges. Every person building models has their own set of data, code, unique compute environment, custom model parameterization. This causes huge reproducibility problems. Let's talk about the data, which is the fuel that builds these models. The cloud has unlimited shared storage. The thing about Azure Machine Learning, though, is it can version data sets. Since data is part of the model building process, versioning creates stability and reproducibility. For example, if we need to revert to a different version of the model, we'll have the version of the data set as well. Let's talk about the code. Managing code is kind of a solved problem in the cloud. With cloud services like GitHub, managing code has become second nature to developers. These innovations also apply to machine learning practitioners. Your code is safe if you're using GitHub. Let's talk about compute environments. Environments include both the software and the hardware configuration to train these models. The cool thing about Azure Machine Learning is that it stores the notion of environments as an artifact. These named environments can be shared or reused. This actually helps a lot, again, with reproducibility. Environments can then be used to train or even deploy models, both locally and in the cloud. With cloud scale compute, the hardware environment can scale both vertically and horizontally to minimize training time and to make it easier for people to use your models in production. Now let's talk about some responsibility here. Part of the responsibility of making models is making sure they are ethical. From a responsible machine learning perspective, there are three things we need to do with models. We need to understand what they're doing. We need to protect people's data and how they're being used, the models, and we need to control what's going on. Let's talk about understanding them. Azure Machine Learning helps us understand models using built-in model interpretability capabilities, as well as fairness assessment and mitigation capabilities. Protect. Azure Machine Learning supports differential privacy that enables folks to build machine learning models using sensitive data while safeguarding the privacy of individuals. And now, managing models or controlling them, similar to how we manage binaries, is also easy in Azure Machine Learning. Each asset can be individually numbered and tagged to give users a clear idea of what folks are using in production. This includes lineage to the exact training run all the way to the version of the data set used to generate the model. Inexpensive infrastructure is also available to quickly deploy and test a containerized version of the model. Speaking of deployment, managing how models are deployed can often be a difficult process. Issues including serving frameworks, availability, scalability, and hardware management of machine learning services can be really time-consuming. The cloud manages all these concerns as services that are consumed. Built-in Kubernetes serving clusters can be deployed and instantiated easily with a click of a button. Deployment of services is handled by Azure Machine Learning Service. Scaling is also built in with GPU-enabled services. Now, a word about GPUs. GPUs make model training much faster, as well as serving much faster. You should really look into using those. Monitoring models in production can be thought of from two perspectives: monitoring from serving infrastructure and monitoring from the inference data, looking from the outside and the inside. Let's talk about serving. With the cloud, you can monitor things like output data, responses, request rates, response times, failure rates, and exceptions without any effort. Now, on the inside of the model, with machine learning models, it is also useful to monitor the data that is passed into the services to answer important questions regarding some of the model assumptions that it learned from existing data. Once collection is enabled, you can monitor for data drift, analyze collected data using Power BI or Azure Databricks, and you can make better decisions about when to retrain or optimize your model. And you know what? You can even retrain your model with the collected data. Let's talk about the whole end-to-end process and go into a little bit of a summary. At every point in the process of providing value with machine learning, the cloud also adds amazing value. One final area where the cloud excels is in automating the entire end-to-end process with some of the MLOps best practices. With services like GitHub Actions or Azure DevOps, practitioners can automate any portion of this entire process to provide smooth end-to-end model training, validation, deployment, as well as monitoring. Simple automation examples include retraining models when the code changes, data drift is detected, or simply even on a schedule. If you want your machines to work on Saturdays, they don't care. Machine learning has changed the way we look at complex problems, and the cloud has simplified and enhanced the process of increasing the pace of innovation in the space. And that's it. Today, you have seen how machine learning and the cloud go better together, especially with Azure Machine Learning.